We're showcasing the ZEISS O-DETECT, which is a vision system for measuring precision parts. This part we're going to measure today is off of a bow and arrow trigger system, and this one has some unique contours on that makes it difficult to measure with a tactile probe. Therefore, this one has a camera system. With a camera system, you have backlighting or transmitted lighting coming up from the bottom, reflective lighting coming from the sides, or coaxial lighting coming right through the optics and the lens of the camera system to see inside deep holes and a variety of different features for connectors and so forth. Optional on the O-Detect is a tactile probe, so that if you do want to get some height measurements and measure some features, then you can do that as well. Here we have blue light as well as light as an option, and this is a full CNC machine platform that is run with Eclipso software, and let's just run through the demo of measuring some contours and features on this part that's already been set up, and then we can go through some of the details real quickly. So here we'll just go through here. It is on the machine. I have picked up where the part is, and now we will just run the start of the program. It'll go through here. It's going through an auto-focusing point to figure out where the actual top of the surface is. And then we're going to go and orient the part so it knows where it is. And then it will do a contour around the part, and then do a circular measurement, and then also give us an actual display of the accuracy of that part. And then utilize that to determine if the machining process is proper, or if we need to make some adjustments for tool wear or something of that nature. Here we have the details of the part, and we'll go here, and dimensionally as well as the contour itself, and that is customizable with the PyWeb reporting. And then we also have the ability to go in and move the part itself, or we're actually moving around on the part to see the different features, and have that related back to the CAD as well as an overlay, which is really nice because that way you can kind of see exactly where you're at in the part as you transition from top to the bottom of the part, with the CAD visible as well as the workpiece under test. The other option is if we have another workpiece and we just put this workpiece on the table here, we can go and have a fixture to automatically pick up that location, or we can actually go through and measure that workpiece. And that's as simple as running the program, but telling it that we need to do a manual alignment. We can start with moving over to where that workpiece is. Here it's telling us and what it's looking for, 3 points on the plane to define where the part is. And here we're going to go and move over to that second part that I put on the table. And here's that part right here. And we'll just come into this part a little different height-wise, and then hit trigger the auto-focusing points where the system moves the z-axis of the CMM to determine where the actual focal point of that top surface is. And then we'll do another one. And thirdly, one last point. 3 points make a plane. And then it's going to ask for the actual line, which gives us the orientation of the part itself. And so we'll do exactly that with our line selection tool here. Pick this line. Picks that line. We'll say OK to our next one. And our 0 point is this circle here. So we'll go in and select that circle. Then tells us that it's going to go take off and measure the part itself. So it goes and predefined positions of those top surface autofocus points, goes to those positions, finds the circle, and then automatically does a contour on the part, just like it did before, although this is of the next version of the part. And then it gives us a very nice graphical display of our outside contour, diameter of the hole through, and what we're looking at there. So therefore we can go through now and actually take a look at the report, or we can go through and look at the outside curve here as well. And take a look at those contours. And right there. And go in here and look at where the and then look at that outside curve here, and then it shows a deviation from the nominal profile of what that part looks like, and then we can relay that to the manufacturing process to basically make a part that performs properly within the mechanism. And that is the O-Detect. This is the 322. There's also a 543 version of this platform, and that is 300 by 200 by 200 volumetric cube that it can measure within, or the 543 is 500, 400, 300 that it can measure within that cube. And that is a ZEISS O-Detect. Thank you. This is Dave in the OptiPro Systems.